the last one.
Which one is it?
The last one!
I'm not listening, okay? My God.
Which one is it?
Which one is it? Go! Walk. Go. Do they always fill up every desk if I'm not here?
Yeah.
Like, is someone not gonna have a seat?
Yeah.
No. What?
No. Actually, I knew that surprised me.
The stuff?
Here, you can take here. Maddox, I bet somebody's not gonna
Maddie was gonna put this.
Oh, you can see. He's gonna sit up there.
I just realized this is not my spot. It's with Morgan's playing it out.
Can you, is it your
Hello.
I'm sorry. So I didn't understand the.
I'm sorry.
That's like right down.
Okay, there's one set
here, though.
I'm pretty sure it's gonna be someone here too.
Who's that for? My sister.
They all.
Oh,
You should sit down.
Oh, here.
What?
You could try this.
My buddy.
I would, but
Just stay quiet forever.
So
Wait, is Hannah?
What's better than your tires?
well, I don't know what that is.
kind
I'll
of.
put it for my podcast.
It's like at the side of my eye, not on my cheek.
Oh yeah, Hannah.
There
There we go. Just take
like 1 through 8, all I got was like
180 and 90.
Yes, that's what I
What did you get for
Go ahead and get out your homework
Right.
and start checking.
I got writing and wrote.
I
I get up so early. Why do you get up so early? I don't know. You live like right by nothing to do. Why do you sleep?
I got writing and wrote.
Go back and sleep. Like 5:30. He gets up at like, yeah, like that's how early he gets up every day. It's like 5 o'clock and he's like, good morning. Why are you awake? What? Makes no sense.
But I said
Why?
definition of
Yeah,
I have the definition of perpendicular. Okay, and then for 10 I have a definition of perpendicular.
Same.
And then for 11 I have a definition of right angle.
Yep.
And then
I got the definition of the left angle.
And then doing
Left
and then complementary
I definition of supplementary.
Yeah.
It's probably
I don't.
For 9 and 10, I got theorem 2.
Why do you do this? He thought. Oh yeah, to make fun of him. Like I'm not that mean. I'm not sarcastic. So I like the mark on my head. That kind of hurt.
You get anything for the
Have
hospital?
that one and then
I think so. But I have to make fun of him. Text 2? Okay, I don't understand.
Okay, yeah, you know when my electronics fall and they're kind of stale, but they're in there. Okay,
Let's
they're
make
just
that 2
still.
4. Okay? Okay.
I just get 2 4.
I don't know. 2 5.
2 1 was like, no, you're decided to just line and a line and the angle is complementary.
2 5. Okay.
Yep, they are stale, so I'm sorry. They've been in there for a while.
What does it smell like?
2 1.
And then 2 6 and 6 have 0 2 6. Yeah.
Yes, that's my next.
Okay, and then
Yeah,
the definition
So
of
it's just
right
have a
angle.
definition of right or
And then
definition
I got
of
like
complementary.
And then
No, there.
And then
I mean, I'll just fail my test.
I don't understand.
And then
2-1.
What you get for 9 and 10?
uh-huh.
Definition of perpendicular line,
Yep.
definition of right angle,
Uh-huh.
angle at posture.
Well, I got the first one. Theorem. I did get definition for
Yes. So I know.
Say that again. Perpendicular.
So the only ones we have different. Yeah, I know. We had like half of them wrong. Okay. So what do you have?
9, I got
Yeah.
perpendicular line.
It makes sense.
And then I got there.
I know.
And I
But like
I'm
it
probably
takes
right.
it, these I just don't know.
That's what I have.
I don't even remember. I don't know because that's.
I know the definition of right angle.
This is like
And
without
then okay,
perpendicular.
grade
this is
both
with
the same
the-
one. And then for 4 through 6, I have 3 through 7 for all of them.
I don't know what I'm saying.
Oh, really?
I don't understand. I'm sorry.
So,
Substitution principle and definition.
Is it English?
Yeah.
English. I don't think my mom's gonna let me buy 2
I can figure it out.
I think your mom is going to. Wait, why 2? Why would you need 2?
by the way, my mom
funny,
mentioned
they were
that
best
instead
friends,
of
right?
like
Hand in
capes
hand,
that we should
hand
have like,
It's not funny.
those like
Yeah.
poncho things, like
It's hilarious.
poncho
They're
things
going
maybe.
full out.
Oh no.
So are you just like gonna not wear it?
Yeah.
too?
Yeah,
we can talk about it. See what we
Yeah.
have. But do you have like 3? It's like but yeah, we can talk about it more and figure out what. First, we need to find out what we
go
have
around.
first.
Yeah.
Okay, are you guys done checking?
Yes.
Yes? Okay.
That's your costume.
No, I'm gonna get a white.
I have this because it
Alright,
But
what
it's like
question?
substituting that into that.
There?
Huge teddy bear. I'm gonna
Number 9.
straps on it.
That's pretty accurate. It's great. You need to show this as well.
And make it into
And then
a hard question for 24.
Because then,
Okay, if angle AXD is a right angle, then line AB is perpendicular to line CD. Anytime they're specific about saying that it's a right angle, it's probably going to be the definition of perpendicular lines. All those other theorems are talking about how angles are congruent, basically that right angles are congruent to other right angles. So if it makes specific mention that it's a right angle, which it does in number 9, then it's going to be the definition of perpendicular lines. Other questions? Aaron?
Could you explain number 11?
Number 11, if the measure of angle CXB equals 90, then angle CXB is a right angle. Well, that would be the definition of a right angle, because if you have a right angle, then its measure is 90 degrees. Okay, does that help? Other, Lauren?
For number 10, since it talks about right angles, does that mean it's the definition of perpendicular?
Yes. Page?
Can you explain number 8?
Number 8, exercise 1 through 7 show that when one angle formed by 2 lines is a right angle, all 4 angles are
Would that be congruent?
what?
Would it be congruent?
Right. Well, that's true. I was going to say right. If one angle formed by 2 lines is a right angle, then all 4 angles are right angles, but they will all 4 also be congruent.
But right is what they're looking for.
I don't know. Either one would be acceptable. I don't know what they're looking for. I don't have the answer key to this book. And the lines are perpendicular. I would probably say right, but they would also be congruent. That would not be wrong. Madeline?
Number 24 on the proof.
On the proof. That would be the definition of perpendicular lines.
Okay, thank you.
Aaron?
Could you do 25 and 27? Those are like two that I didn't.
25 is also the definition of a right angle, because it says in step 24 that the angle is a right angle, and then it says that it is 90 degrees, so that's the definition of a right angle. And which one did you say?
27?
27 is, I believe, substitution. Yeah, substitution.
Okay, thank you.
Principle. Other questions? Do you guys feel pretty good about the homework from last night? Wolfie?
I don't understand the proofs. Like, when you do them, that makes sense, but like I can't do it myself. Like I think like there's just so many possibilities that like how do you figure out what's what without, because like for 27 you could, I was thinking you could also say angle addition or like,
Well, did you use angle addition for 26?
yeah.
See, I would use angle addition for 26, and then since in 27 they're relating that back up to 25 where it's equal to 90, that's why it would be substitution.
Okay.
It's very difficult to explain, like, how to do, on your own. I was thinking what might be helpful and what we might want to come up with is, as a class, come up with a list of all of the definitions and theorems that we have been using in proofs, and give like an example for each one of like what it would look like, so for angle addition postulate, we always know it's going to be this angle plus this angle equals this angle. That has to be what it looks like for angle addition postulate, and maybe come up with a list that we could all refer to.
That'd be really helpful.
Okay. Rather than me just make it for you, we'll figure out some way that we can all help with that and compile it together so that we all have a part in that. Okay. And then, like, I really don't expect you. There's a lot of theorems that we're going to be using in this chapter that only have numbers, and I really don't expect you to memorize the numbers of the theorems. It's kind of pointless, and it all depends on your book what number they use. So like if we got a different book, it would be a different number. So if we come up with that list, then we'll just keep a running list throughout the year, and then you can use that for like quizzes and tests and homework and whatnot. Does that sound good? Okay. We'll work on that. Any other questions, comments, concerns from last night?
Number 24.
Yes, ma'am.
I got theorem 2.5, but I didn't know if that was correct.
Theorem 2.5 is saying that they're congruent angles. And since this is saying that it's specifically a right angle, that's the definition of perpendicular lines. Okay? Anything else? Alright, go ahead and get out your notes.
I can't find my notebook. Can I see this in my locker? Thank
Okay, theorem 2.9, and at the very top of the section it says, in proofs, sometimes statements can be written in pairs supported by the same reason. So if there's two statements that you want to make in a row and they're going to have the same reason, then you can just put them in one step and this the reason column. So theorem 2.9 says if two angles are complementary to the same angle, they are congruent to each other. So if we have, say, angle 1, angle 2, and angle 3, and if we say that angle 1 is complementary to angle 3, and angle 2 is complementary to angle 3, then we can say that angle 1 is congruent to angle 2. Does that make sense? Questions about that? Theorem 210 says that if two angles are complementary to two congruent angles, then they are congruent to each other. So if we know that, let's see, we'll have 4 angles. If we know that angle 3 is congruent to angle 4, and angle 1 is complementary to angle 3, and angle 2 is complementary to angle 4, then we know that angle 1 is congruent to angle 2. So if you're given 2 congruent angles and 2 other angles are said to be complementary to those 2 angles, then we know that they're also congruent. And then we have similar theorems for if angles are supplementary. So 2 angles are supplementary to the same angle and they are congruent to each other. So that's pretty much just like theorem 2.9, except for with supplementary instead of complementary. So if we have angle 1, oops, angle 1, angle 2, and angle 3, and we know that angle 1 is supplementary to angle 3, and angle 2 is also supplementary to angle 3, then we could say that angle 1 is congruent to angle 2. Okay. Theorem 212 is very similar to Theorem 210 except for with supplementary angles. So if 2 angles are supplementary to 2 congruent angles, they are congruent to each other. So that would be like saying that angle 3 is congruent to angle 4, and angle 1 is supplementary to angle 3, and angle 2 is supplementary to angle 4, then angle 1 has to be congruent to angle 2. Okay. Alright, before we get to that, we'll get the oral exercise. Did everybody get all the notes? No, sorry. So let's look at the oral exercises on page 60 and 61 in your book. In the plane figure, ray RS is perpendicular to line TV. Name the figures described. So number 1, who can tell us what one right angle would be? Morgan?
RST.
I know what you're referring to, but you need to...
SRT sign.
Yes, SRT, good. And what would be another one? Aaron?
SRV.
Good. Okay, number 2, what would be an obtuse angle? Sarah?
XRV.
XRV, good. Number 3, a pair of complementary angles. Paige?
GRX and XRS.
Good. Number 4, 2 angles that are supplementary but not congruent. Wolfie?
XRV and XRT.
Okay, good. 2 congruent supplementary angles. Mac?
SRT and XRE.
Good. And 2 angles that are adjacent to angle XRS. Madeline?
SRV and XRT.
Good. Any questions about those? No? Okay. Given the plane figure with angles having the measures shown, name the figures described. So number 7, 2 complementary adjacent angles. So complementary means they have to what? Equal 90, and they also need to be adjacent, so they need to be next to each other. Wolfie?
Would it be BAC and CAD?
Yes. Good. Number 8, 2 complementary non-adjacent angles. Okay.
CAD and ACD.
Good, because angle CAD is 50 degrees and angle ACD is 40 degrees. They will add to be 90, but they are not adjacent to one another. Number 9, 2 right angles. Wolfie?
A and D, angle BAD and angle CDA.
Okay, good. And I like how you corrected yourself. We can name angle D just as angle D because there's only one angle that has that vertex. but we cannot name an angle angle A because
Oh,
there's two angles that come off of that vertex. Okay? Number 10, an angle that's supplementary to angle BCD. H?
ACD?
Did you say ACD?
Yeah.
What does it have to add to equal to be supplementary? 180, and how much is, or what is the measure of angle BCD? 120, so we're looking for an angle that is
60. So,
60, back,
CBA.
CBA, okay, good. Number 11, two segments perpendicular to AD. Sarah?
Segment AB and segment DC.
Okay, good. How do we know that those are perpendicular to AD? Nancy?
Because they're 90 degrees.
Right, because they form 90-degree angles. Very good. And number 12, an angle with vertex C that is not adjacent to angle BCA. Adam?
Oh, never mind.
Mac?
DCB.
Yes. DCB. Okay, so there's three angles with vertex C, right? There's this angle here, which is BCA. So that's not the one they're talking about because it has to be not adjacent to that. There's this angle here, ACD, that is adjacent to it. But there's also the angle that goes all the way across, so that would be BCD, which is not adjacent to this angle because they have points in the interior in common. Okay, any questions about any of those? Okay, then your assignment is on pages 61 and 62, numbers 1 through 16. And tomorrow, let's start compiling a list of all of the reasons that we've used in our proofs. So if you could bring like your old homework assignments and your notes so we can start writing down the reasons that we've used. Because we have some theorems that will probably never be helpful in a proof. So if we haven't used it in a proof before, we're not going to include that on the list. We want to pare it down to the ones that we're going to use. And there's some that are a lot more common than others, so if we could try to put them in order from like substitution principle we use probably in every proof, so that's probably gonna be the first one that we put. So just when you come to class tomorrow, along with your assignment, just have some of your old proofs with you so that we can start making a list of the reasons that we have used in the past, okay?